In question number 17, we have been asked which one of the following exhibits highest bond order. For that, we have to draw the molecular orbital of oxygen. So that will be, say, this is 1s, that is 2s, 2s, and that is your 2p orbital for two separate oxygen atoms. Okay, so this is oxygen atom say 1 and this is oxygen atom 2. This is the energy axis. So when 1s and 1s combine, there are bonding and anti-bonding and bonding orbitals. So this is the anti-bonding, this is bonding, this is bonding, and this is your anti-bonding. Okay, coming from the 2s, there are 6 orbitals combining for the 2p, so there will be obviously 6 molecular MOs, and for that we will say this is the bonding, that is the anti-bonding sigma. Okay, and this is the bonding pi orbital, there are 2 of them, and this is pi anti-bonding orbital, there are 2 of them. Now oxygen is obviously having a total of 8 electrons. Okay, so obviously it will be 16 electrons. So let's fill up 16 electrons over here. So say this is 1, 2, 3, 4. So these electrons get cancelled as in bonding and anti-bonding. 1, 2, 3, 4. So all total 8 electrons now. 9, 10, 11, 12, 13, 14, 15, and you have 16. So the bonding and anti-bonding electrons coming from 1s will cancel each other. Bonding and anti-bonding electrons coming from 2s will cancel each other. So for our bond order calculation for only O2, bond order, when we are doing only O2, that will involve 6 minus 2. So we will say it is going to be around 2. Okay, so our bond order for O2 is around 2. Now if you think of O2 minus, that means another electron over here, additional. So for a O2 minus, it will be 6 minus 3 by 2. That means it is going to be 1.5. For a O2 2 minus, that means another electron over here. So that means it is going to be 6 minus 4 by 2, which is going to be 1. However, for O2 plus, it should mean only 1 electron over here. So it is going to be 6 minus 1 by 2, and that should be 2.5. So the species having the highest bond order will obviously be the last one, that is the option number D. In question number 18, they have asked how many resonating structures are possible for NO3 minus ion. So let's see the structure of NO3. The structure of NO3 is something like this. So The other possibility is this is minus, that is double bond, and that one, or the other possibility is this way, the double bond that remains as minus. So here we can see there is a possibility of 3 resonating structures for a nitrate ion. In question number 19, they have asked, consider the following statements for the complex Ni NH3 whole 6 Cl2, and we have to find out whether it is an outer orbital octahedral complex. Hybridization of Ni is sp3d2, it is a paramagnetic complex, or it is a diamagnetic complex. So for this, one has to use valence bond theory. So using valence bond theory, that is VBT, we know that out here the charge of the complex over here is +2. NH3 is a neutral ligand. Okay, this is a neutral ligand. That means the charge on Ni has to be 2. That is the oxidation state. Now Ni2 means, so for that if we write the electronic configuration of Ni, which is obviously nickel is 28, that means it is Ar 4s2 3d8. So Ni2 plus is basically a 3d8 system or a d8 system. That means if you write the orbitals, keeping the energy levels in mind, so this is the 3d orbital. We will make 5 such boxes over here, followed by a 4s orbital, followed by a 4p orbital, and followed by a 4d orbital. That is how we will arrange the boxes over here. So now NH3 is a neutral and a weak field ligand, so for that the electrons have to be arranged in the following manner. So as we can see, it is having 2 unpaired electrons, so it is a paramagnetic complex. So this statement has to be correct. Now for the ligands, electrons, 2 electrons will be for each ligand, so total there is 6 such ligands. So we will fill up the 6 orbitals, which is s, p, d. Okay, so it will be basically a having the hybridization sp3 d2. Now since we are using the 4d orbitals, so we will say this should be a outer orbital complex. Okay, so the hybridization is sp3d2 and it is our outer orbital complex. So the statements that are true over here are 1, 2, 3, and that should be our correct option.